Okay, hi. Good morning to all of you. Welcome to Lecture 3. Okay, you are at the right area. You're at the right place. This is the 17th of April, Friday, and this is our last part of the enzyme chapter 4. Okay, so after today's lecture, you must be able to describe how pH affects enzyme activity. All right? Okay, now what did we cover for the previous chapter on 15th of April? The previous lecture, lecture 2, what did we cover? We actually talked a lot about the lock and key hypothesis. Okay, we actually said that enzymes are of a particular shape, and this shape, the active site shape, has to be complementary to the shape of the substrate. Okay, so this is your enzyme and this is your substrate. Okay, so once the substrate has the same shape as the shape of the active site, okay, the enzyme and the substrate can combine to give you a ES complex known as an enzyme substrate complex. Then this will undergo a chemical reaction to give you products. And so why do we say it's a lock and the key? We say that your enzyme is the lock because it doesn't change, and your substrate is the key. Okay, that's why lock and key hypothesis, which is actually telling you that enzymes are very specific because of the shape of the active site. All right, then after that, we also talked about the second thing, which is about how temperature affects enzyme activity. Okay, so we had a few things, right? We say low temperature, the enzymes are inactive because not enough energy. So the enzymes and the substrate move very slowly. And because they move very slowly, they collide less with each other. Then as temperature increases, they become more and more active, so they collide more, and then the rate of reaction increase because more products are formed. Then we said this is a very important temperature. Enzyme is the most active at the optimum temperature. Optimum temperature means the best temperature, okay? The ideal, perfect, okay? Perfect temperature. Then when the temperature becomes too high, so I'll draw for you the graph. At first it's very low because the rate of reaction is very low. Then it slowly increases all the way to a particular point known as the optimum temperature. In human beings, this is 37 degrees Celsius. After that, it will start to drop until it becomes 0. Now, why is that so? Because at this part here, we say that the enzyme has become denatured. Now, some of you all remember what they Miss Lee teach, right? Denature is when the shape of active site is changed. Okay, and since the shape of the active site is changed, the enzyme is less active, the rate of reaction will decrease and it will become 0. So this was what we actually covered for the previous lecture on the 15th of April. Now let's move on to today's lecture. Now there is a small correction or a mistake, a small wrong thing that you have to change in your notes. So can you please, instead of the effect of temperature, it should be change, cross out temperature and write there pH. Okay, this graph is actually talking about pH, it's not temperature. So please cross out the word temperature and write in pH. Okay, now if you notice the pH graph, it looks like this. How do we interpret the pH graph? Very simple. Let's have a look over here. You don't have to fill in your notes here today, but you just need to listen to Miss Lee because this is quite an important part. Okay, so what happens at low pH? Let's have a look at this pH here. Now, low pH means is acidic. So this is low pH. 7 and 7.5 is actually neutral. 8 and above is alkaline. Okay, so at low pH, the rate of reaction is very low. Can you see? Actually, it's 0. Then as you increase the pH, it becomes higher but still low. When you increase to 6, it becomes slightly higher. 7, it becomes higher. And the optimum pH is when the enzyme activity, the optimum pH is here. This is when the enzyme activity is the highest. So you can see here that at low pH, the rate of reaction is very low because the enzymes are inactive. Now, as you start to increase the pH, you notice that the rate of reaction or the enzyme activity becomes higher and higher, right? So that means that as pH increases, the rate of reaction increases only until this point here. Because you notice that when the pH increase after 8, does the graph go up or does the graph go down? Good. The graph actually doesn't go up, it actually goes down. That means this part here, okay, enzyme activity is decreasing. That means the enzymes are becoming less active, okay, until they have 0 as their activity. So when the optimum pH is reached, we say that the rate of reaction is the highest beyond. Now the word beyond means after that. Okay, so what happens after pH 8? What happens after pH 9, pH 10? You notice that the rate of reaction actually becomes lower and is decreasing until it reaches 0. Why does this part take place? Very similarly to temperature, because it is denatured. So you notice that there are two keywords here. One is inactive at low pH and one at a pH that is after the optimum pH. Then we say that it is denatured. Okay, so you can pause the video anytime to write down notes, which I will encourage all of you all to do so. Okay, so let's interpret the graph together. So we say that at number 1, the pH is very low, so the enzymes are inactive. As the pH starts to increase, you notice that the rate of reaction also increases until the optimum pH, which is number 3. That is when the enzymes are the most active. That is why your enzyme activity is the highest here in the graph. Then beyond the optimum pH, which is pH 8, how do you know that this is the optimum pH? You just look for the highest activity, you draw a line to the graph and you draw it down, then you read the value here. Okay, after pH 8, you notice that the graph starts to decrease until it becomes 0 here, because we say that the enzyme activity is very low or close to 0 because the enzyme is denatured. So you may want to write down that denature actually means that the shape of active site has been changed, or we say lost or damaged. Okay, so this is the graph of your pH. If Miss Lee were to draw a graph of your temperature, you will clearly see that there is a difference. Okay, so let me show you. Your graph will go up like this and then it will go all the way down. So you notice that your graph of your pH is quite symmetrical, okay, whereas your temperature graph looks a little bit not the same. Okay, in fact, if I were to draw it now, it will look something like that. And then it will go all the way down here. Okay, so you will notice that the graph looks slightly different. Okay, so congratulations, you have come to the end of the lecture of enzymes. But before you stop the video, there is some work for you to do. Okay, let's watch this simple animation first. Now you see what happens. Amylase enzyme actually has an optimum pH. Okay, amylase enzyme we're going to be talking about here has an optimum pH of 7 to 8. So actually amylase, which breaks down starch, okay, it works best when it is pH 7 to 8. That's the neutral pH. That's why amylase is always found in your saliva. Okay, then you see the graph looks like this. All right, you can tell that the rate of reaction at about 7.8, okay, is the highest at 15 arbitrary units. So the rate of reaction is the highest. Therefore, this is the optimum temperature. The optimum pH. All right. So you will notice that at very low pH and at very high pH, your enzymes are actually denatured. And you will notice that there are some enzymes that have got optimum pH at very low or acidic pH. Now, why is there a difference? Because different enzymes in different parts of your body require different pH. Just like different organisms have different optimum temperature. Bacteria that stay in a volcano, the optimum temperature will be 1000 for the enzymes. But the bacteria in your body, the optimum temperature will follow your normal body temperature, which is 36.9 to 37. Just like in your body, different organs in your body have got different pH environment. So some enzymes here like pepsin, remember the word pepsin? Pepsin sounds like protein. They break down protein. All right, they are actually they work best when the pH is very low or very acidic, pH 1.8 to 2. Whereas some enzymes require a pH that is slightly more neutral. All right, any pH that is below or above the optimum is not good working environment for the enzyme. Okay, so now at the end of lecture 1, 2, and 3, you should be able to do this. Number 1, you should be able to define what is an enzyme. You will be able to describe the properties of an enzyme. So what are the characteristics? It's very specific. You need it in small amounts. It is the lock and key hypothesis describes how it behaves. It is affected by temperature and pH. You should be able to describe the lock and key hypothesis. You should be able to explain how temperature affects enzyme activity. And today, we spoke about how pH affects enzyme activity. So this is actually what we have covered for the past 1.5 weeks. Okay, so now, before the video comes to an end, please take out your 10-year series topic 3. This is how it looks like. Okay, your teacher will have photocopied for you, all right, or emailed you if you don't have a copy of your 10-year series. All right, please look for topic 3 under biological molecules. Please complete the following 6 MCQ questions. Questions 2, 4, 6, 7, 9, and 15. Okay, you can take 13 minutes to complete this, because after that, your teacher will have a Google Meet with you. Your teacher will WhatsApp you the Google Meet link so that we can give you the answers to these questions. Now you can pause the video here to circle the questions in your 10-year series. Alright, so your teachers will see you after you complete these 6 MCQ questions. Thank you.